Hello everyone, my name is Lutfi, and now that we have covered the structure of atoms and all that in my previous videos, now we can move up the hierarchy and gain knowledge about how atoms combine to make larger, more complex molecules, more complex structures, and which their names are molecules and ionic bonds. And I recommend watching my previous videos, but if you don't want to watch them, at least just look at the description and the subject of those videos and see if you can see if you know anything about them, and just be ready for these videos, because we are not going to talk about the previous subjects in these videos, okay? And I don't want to bore you, so let's get started. Okay, so these are the main subjects for this video, and as you can see, the subjects are very large in size, no, large in numbers, because I want to make up for lost time. Okay, so now let's get started. So atoms that have incomplete valence shells can interact with other certain atoms in such a way that each particular atom completes its valence electrons, valence shells. Okay, sorry. The atoms either share or transfer their valence electrons. Okay. So these interactions usually result in the atoms staying close together, which are held together by attractions called chemical bonds. Okay, so what are different kinds of chemical bonds? Okay, so the strongest kind of chemical bonds are the covalent bonds. Okay, and there another bond, chemical bond, that is a little bit weaker than covalent bonds or ionic bonds. Okay, we have two other bonds, chemical bonds, but we are not going to talk about them in this video because of the size of the video. So yeah, we are in this video we are only going to talk about covalent bonds. Okay, and have in mind that uh, some ionic bonds, no, just ionic bonds, okay, their dry kind, okay, is more stronger than the aqueous kind, or the water-based kind. Okay, and we will learn about why this ionic bonds are like this in the next videos. Okay, so covalent bond is the sharing of a pair of valence electrons by two atoms. Okay, for example, let's consider when what happens when two atoms of hydrogen atoms approach each other, as you should know, hydrogen has only one valence electron. Okay, and as you know, every atom wants to fill its valence shell so that it can be happy. Okay, so I have a question for you. What is the capacity of the first shell of the first shell? Okay, mainly the 1s shell. Okay, so you can pause the video to think, but I don't think you need to think. It's really easy. Okay, so the answer is 2 electrons. Okay, So when two hydrogen atoms get close enough so that the one s orbital overlaps, they can share their electrons, okay? And you can see that in this picture over here, okay? Okay, so and when they share their electrons, both of the atoms will now be associated with two electrons. So, in conclusion, this their valence shells are now full and they are happy atoms. Okay, so some of you might be thinking, so what are molecules? Okay, molecules are when two or more atoms come and covalently bond with each other to make larger complexes, that these complexes are named molecules. And you can see some examples in the left part of the screen, which one of them is H2O, water, carbon dioxide, and you know what that is. And so, yeah, these are molecules. Okay, so this picture over here, okay, shows how two hydrogen atoms covalently bind together, okay, and its formula is H2, okay, which which it simply indicates that this molecule is made from two hydrogen atoms, and so the two number which is under each element, in this case hydrogen, shows or indicates the number of atoms that there are in this molecule, okay. So, and the hydrogen is a symbol of the atom, showing what atom is present in this molecule, okay. So this is how you read a formula, okay. So electron sharing can be depicted by an electron distribution diagram, okay, and this is the picture of an electron distribution diagram, and it can also be depicted by Lewis dot structure, and this is the picture, and Lewis normal structure, which is, as you can see over here, and ball and stick model and space filling model, okay. So I will now talk a little bit about each one, okay. So the Lewis dot structure, okay. The Lewis dot structure is a structure when two atoms, okay, two or more atoms, when they come together to covalently bond, okay, the two elements, as you can see, are written, okay, in this case hydrogen, two hydrogen atoms, and the valence electrons are shown as little dots or normal dots that are surrounding that atoms, okay. And so the Lewis structure, as you can see over here, is when two or more atoms come together to make covalent bonds, okay, the atoms are written, but the electrons, okay, only the electrons that are shared between these two atoms are shown, and they are shown as lines, okay. So one line means one single bond, okay, and but some atoms can make two lines or double bonds, and some even can make triple bonds, or which they are shown as three lines, okay. And that's all for Lewis structure and ball and stick model. Okay, before we go to that model, there is something I want to tell you. The differences between the Lewis structure and the Lewis dot structure are written in this orange box. Okay, and you can just write it down somewhere. Okay, so that you don't have to always come and watch this video. Okay, so the ball and stick model. Okay, in this model, as you can see in this bottom picture, okay, the atoms are shown as these balls or spheres, which each of them have different colors showing different atoms. Okay, and the sticks which are between them show the bonds between them. Okay, so some atoms like hydrogen make only single bonds. Some atoms like oxygen make double bonds. Okay, and nitrogen makes triple bonds. Okay, this is very important as well. Okay, so the next one is the space filling model. Okay, so in this model, atoms are shown as these big spheres, okay, but the bonds are not shown. And this model is the closest kind of model to real life atoms, okay, because atoms are big spheres, okay, which these electrons move in these orbitals, okay, which in 90% of the time they move in these spherical patterns, okay, which we cannot say patterns because they don't go in one direction, and we can't say where the electron will be a second after this. Okay, so yeah, they are just big spheres which are inside each other, I think. Okay, so now let's go continue this video. So each atom that can share valence electrons, it can form covalent bonds corresponding to the capacity of the valence shell and the number of valence electrons. Okay, so when all the bonds that an atom needs to form, they form. Okay, they give the atom a full, complete electron valence shell. Okay, sorry, and so they fill the bonding capacity, no, the capacity of that shell. Okay, and different atoms have different capacities in their shells. Like for example, the atom oxygen has a capacity of 2 electrons that it can bind to. Okay, and as you can see in this picture, there are 2 atoms that are alone. Okay, and they have to be like these other atoms have another partner besides them. Okay, so when the atom gets 2 electrons, maybe from covalent bonds, maybe from other places, okay, it will have a complete valence shell and it will be happy. Okay, so this bonding capacity is called the atom's valence. Okay, it usually equals the number of unpaired electrons required to complete the atom's valence shell. Okay, and now for the pop quiz. Okay, now you find the valence of oxygen, hydrogen, and nitrogen and carbon using this graph. Okay, you can pause the video and calculate. Okay, so the answers are okay. So valence of hydrogen is 1. Okay, for oxygen is 2. Okay, these ones were easy because I had told you the answer in this video. Okay, so now for the nitrogen and carbon. Okay, these ones that I didn't talk about their valence, so these ones are a little bit challenging. So for nitrogen the answer is 3, and for carbon it is 4. Okay, and if you got these right, you are a pro at this, and you may continue this video. But if you didn't get them, no problem, you can just go and watch this video again and come back and do these pop quizzes right. Okay, so notice that some atoms, okay, may have different valences. For example, I mean that some atoms, okay, when they get 2 atoms, they are happy. Okay, and even with when they get 3 electrons, sorry, 3 electrons, they will become happy too. Okay, so these atoms, like the atom iron, okay, which has the valence of 2 and 3, must be memorized for real day exams. Okay, so not for my pop quizzes. Okay, but it's good to learn them. Okay, so the molecules H2 and O2 are pure complexes because they are made from the same element. Okay, and they have the same element twice. Okay, rather than compounds, because the compounds are made from 2 or more different elements. Okay, and so these are uh, these are the O2 and H2. So let me get my laser pointer. So this one shows the H2, okay, because it has 2 atoms that are both white, and they show only one element. Okay, and this one is O2, which is again showing 2 atoms of the same element. Okay, but there are compounds, okay, like for example H2O, okay, which they are made from 2 or more atoms that are different from each other. Okay, so these ones are hydrogens, these ones are no, these 2 are hydrogens, and this one is oxygen. Okay, and so in this one, okay, which is methane, it is CH4, so the black one is carbon, and the 4 hydrogens, okay, are they are hydrogens. Okay, and as you can see, we have different colored atoms in this structure. So in conclusion, they are compounds because they are made from 2 or more different atoms. Okay, so atoms in a molecule attract shared bonding electrons. Okay, electrons to varying degrees depending on the element. Okay, so the attraction of a polar atom for the electrons of a covalent bond is called electronegativity. Okay, and the more electronegative an element, the more it wants to pull or hog the electrons that have been given to it or shared by it by covalent bonds. Okay, so these atoms or these elements don't actually share the electrons. Okay, they actually give one no they actually take most of it to themselves, and sometimes give it to the other atoms. Okay, and so an example of this is the molecule H2O, okay, or water. So H2O is made of one oxygen atom and two hydrogen atoms. Okay, but the oxygen atom is more electronegative than these two hydrogen atoms. Okay, so it hogs the electrons from these two atoms. Okay, and holds them to itself. And so have in mind that whenever you go whenever you see a periodic table, okay, when you go up to the up and right corner of that periodic table, the more electronegative the atoms get. Okay, so the electronegativity is stronger there. Okay, so oxygen, because it is in the top right corner, okay, a little bit to the left, but still it is electronegative. Okay, but no, its electronegativity is more. Okay, but because the hydrogens are at the top left corner of the periodic table, their electronegativity is less stronger, okay, than oxygen. Okay, so when these two atoms bind, the oxygen always hogs the electrons. Okay, and as you know, electrons are negative molecules. Okay, they have a partial charge of negative. Okay, so whenever an electron receives more electrons than its normal amount of electrons, okay, it will get more negative. Okay, and for example, this oxygen over here, okay, when it takes or hogs the electrons of those two hydrogen atoms, it becomes partially negative. Okay, and we show it the electronegativity. Okay, we show the electronegativity with delta S. Okay, so delta, which in most cases is shown like this triangle, okay, we don't mean this. Okay, we actually mean the Greek word, okay, which actually mostly looks like an S. Okay, and it is drawn very greatly over here. Okay, so we show it by delta. Okay, and if the electron or the atom is hogging the electrons and it is partially negative, we put a minus in the front of the delta, okay, for that atom. Okay, so in this case, this delta negative is for the oxygen. Okay, but when we want to show an atom that its electrons were taken, okay, so it becomes more how do I say it, positive, and we show it with a delta positive. Okay, something like this. Okay, and you can see that over here, which is for this hydrogen. Okay, So now let's talk about how to find the electronegative minus part and molecule. Okay, so whenever we want to find the polar side of a molecule, okay, we use this kind of an equation. Okay, this is mostly used for H2O or water, and we are going to learn about that in a few seconds. Okay, so now every atom, okay, that has a delta plus, okay, in this case the hydrogens, okay, and every atom that has a delta minus, okay, we put a plus sign, okay, on the atom that has a delta plus and an arrow pointing towards the atom that has a delta minus. Okay, in this case this arrow is showing this one. Okay, and we do the same thing to this the right hydrogen, and so again a point, an arrow, and a plus sign. Okay, and this shows this arrow. Okay, and when we want to so now when we subtract these two arrows, okay, they equal this arrow. Okay, so now how does it be like that? Okay, how to subtract these two arrows is like this. So this arrow is the same as a right-sided arrow, and then another arrow going up. Okay, and this one is an arrow going to the left and another arrow going to up. Okay, so now when we subtract these two arrows, or these four arrows, okay, these two arrows, this one and this one, okay, they actually just cross each other out. Okay, and they are not going to be present anymore. Okay, and what remains are these ones. Okay, the arrows which are going to upside. Okay, so when we subtract them, they just won't subtract because they both are to the upside. Okay, so they equal this one. Okay, because these ones were cancelled and these ones remained. Okay, so the answer is this arrow which is pointing towards up. Okay, so this arrow shows the negative polar side of a molecule. Okay, so the molecule's electronegative side is this side. Okay, so the plus sign shows the electronegative part that is delta plus, and the arrow side shows delta negative. Okay, so and that's all for this video. I hope this video was helpful for you, and if you like this video, please like and share, and if you like, you can subscribe, and so that's all for this video, and happy learnings to you all.